Solving absolute value inequalities, part 2. So we know that in order to work with this absolute value inequality, the first thing I have to do is isolate the absolute value, which means the first thing I'm going to do is change my minus 3 to a plus negative 3. And now I know in order to get rid of this term of negative 3, I'm going to have to add 3 to both sides. That gives me the absolute value of k plus 2 divided by 3 is greater than or equal to 1 plus 3 is 4. So can I think of a non-negative number, that's my absolute value, so a non-negative number which is greater than 4? Yes, there are an infinite number of them, 5, 6, 7, 8, and so forth. So now I want to set up my two inequalities. So my first one, I just drop the absolute values, and I get k plus 2 divided by 3 is greater than or equal to 4. In my second one, I have the same thing, k plus 2 divided by 3. Now I flip my inequality, is less than or equal to, and then change the sign of my number, negative 4. Alright, so I'm going to solve the first one. And the first thing I want to get rid of is this division by negative, or the division by 3, which means I'm going to have to multiply both sides by 3. That's going to cancel here, and I'm going to get k plus 2 is greater than or equal to 12. Now to get rid of this 2, I can subtract 2 from both sides. That gives me k is greater than or equal to 10. So here's my first inequality. Moving on to the second one, I still want to get rid of this division of 3, so I multiply both sides by 3. And that gives me k plus 2 is less than or equal to negative 4 times 3 is negative 12. And then once again I can subtract 2 from both sides, being careful of my signs. So k is less than or equal to negative 12 minus 2 is negative 14. So there's my second inequality. Now I'm ready to graph, so I draw my line, plot 0. I have 10, that's over here, and negative 14, somewhere over here. So my first inequality says k is greater than or equal to 10. So I start at 10, and since it's greater, I want to go to the right. Since it says greater than or equal to, I have to use a bracket. In my second inequality, k is less than or equal to negative 14. Since it's less than, I go to the left. And then once again, since it's less than or equal to, I use a bracket. And we can see in the middle, there's a gap. And we close that gap with union. So my first one is from negative infinity up to and including negative 14. Close it with a bracket. And then to close this gap, I use the union sign. And then it runs from 10 all the way to positive infinity. And that's our solution in interval notation.